All right, welcome. In this video, we're going to be talking about intercept form of a quadratic equation. And so we're going to be doing a lot of factoring because that's how we're going to take a quadratic equation and write it in intercept form. But to start, let's just look at this kind of basic equation that we could factor and sketch its graph. So I know if I want to factor this thing, I'm looking for two numbers that multiply together and equal -8 while adding together to equal -2, right? So, oh no, that's not. So if I think about that, I'm thinking, okay, 4 and 2 multiplies to 8, and they got a difference of 2, so I could probably make one of them negative, and if I made the bigger one negative, we had to add them together and get a negative number. So I'm thinking m needs to be -4, and n needs to be +2. Now you could have said, n was -4 and m was 2, but either way, one of them needs to be -4 and one of them needs to be 2. So we can factor this thing. This is equal to x minus 4 multiplied by x plus 2. Okay. If we want to sketch the graph, what we've done, the only thing we've really used factoring for so far, besides completing the square, has been to find x-intercepts or solve equations. So if this equation was set equal to 0, it would be really easy to solve, right? Okay, I see two things multiplying together to equal 0. One of them has to be 0, so that means either x equals 4, or maybe this thing was equal to 0, and that would be when x was -2. Okay. I think in the first day we did this to find the x-intercepts. Okay, so what we're seeing is that the factored form is good for finding x-intercepts, and that's because it's good for finding where y is equal to 0. Okay. So if I wanted to draw or sketch the graph of this parabola, y equals positive x squared, we know that's going to open up. So I'm just going to put in a vertex, let it open up. And then I'm going to draw in an x-axis. I know I've got two x-intercepts because I just solved for them. And then I'm just going to kind of label them as x-intercepts. Okay, right there, x equals -2 and x equals +4. So the intercept form version of this equation is just where we've got it factored up. Sometimes you'll hear people call this factored form also. Okay, and it's really good for finding x-intercepts. I think that's what I'd say about it. All right, so kind of the key factor today is that if a quadratic equation has at least one x-intercept, it can be written in this factored form. Now in this class, we're probably not going to go with the really extreme cases where, it would be really hard to write it in that form. We're just going to stick to the factoring techniques that we know at this point. Okay, but what I will point out is that x equals p and x equals q, those are my x-intercepts. Okay? So if I was to draw, okay, maybe I'll split it up into the case where a is greater than 0. That would be the parabola opening up and having a couple of x-intercepts. Okay, there would be p and there would be q, or maybe backwards from that, but these are the two x-intercepts. Say one's got to be less than the other. Say it's like that. Okay, and if a was negative, then it would look somewhat similar. And then, we'd have two x-intercepts, p and q, right there. Okay. And that's, I feel like I had something else. Oh, yeah. Something else I could say about this is that in an intercept form, factored form, makes it pretty easy to find the equation of the axis of symmetry, which is something I'm about to ask you to do on that example. Because the axis is going to be halfway in between the zeros due to the symmetry of the parabolas. All right, so if we're given an equation in factored form or intercept form, we can sketch the graph pretty easily just by, kind of being mindful of the direction it opens and labeling the x-intercepts, but it would also make it pretty easy to find the axis of symmetry. So I'm going to start with this one. Okay, I know that from this, the x plus 3 and x minus 1, I'm going to have zeros. That's another word for x-intercept. Zeros at x equals -3 and x equals 1. Okay. And from this, let's say this -2 here, I know that this parabola is going to open down. Okay. So I'm going to draw myself a downward opening parabola, and I'm going to label its x-intercepts. Okay. X equals -3 and x equals +1. Okay. Now, if I wanted to find the axis of symmetry, yeah, I can see it. It's right here. Okay, it's halfway in between the zeros. And so what you can do, then in general, the formula is we're going to add the zeros together and divide by 2. And so what am I thinking? Hold on. Oh, yeah. The axis is going to be x equals, okay, because it's a vertical line, we need an equation. Okay, I would take the first 0, add it to the second 0, and divide by 2, right? It's the midpoint formula is really what it is. And so that's -3 plus 1 is -2 divided by 2 is equal to -1. Okay, so my axis of symmetry is x equals -1. Now, if we want to write an intercept form equation and we're looking at a picture of the graph, okay, we're going to start with the zeros and then we'll figure out what that leading coefficient is after. Okay, so I'm seeing that the zeros are here at x equals 1 and x equals -3. Okay, and I know that the intercept form, it starts y equals some number a, which is the same a as the leading coefficient in ax squared plus bx plus c, the same a as a equals 1 over 4p when we're finding focus and directrix stuff. But I've got a times x plus 3 times, x minus p times x minus q. Okay, maybe I can, just put that a little smaller. Okay, I've determined that p and q are -3 and +1. Okay. So -3 and +1. Okay, and so I plug those in, and now the work I have to do is to find the value of a. So I might go over here and say, all right, down here I've got my vertex is at the point where x is -1 and y is -2. So in order to find the value of a, I'm going to use x equals -1 and y equals -2. Okay. And then I'm going to say, all right, -2 equals a times -1 plus 3 times -1 minus 1. So this is -2 equaling a times +2 times -2. So -4a equals -2. And then I could divide both sides by -2. Wait, no, by -4. And I would see that a is -2 over -4, which is +1/2. Okay. And then I'll just go back in and plug in there. And I've got myself an intercept form equation for that parabola. All right, here's another one. So I'm identifying that the zeros are at x equals 0 and x equals 2. And then I'm seeing the vertex up here at the point where x is 1 and y is 2. Okay. And now I think that the fact, we aren't going to have to worry about the fact that it's opening down and making sure our a is negative. I think if we solve for a correctly, then we'll just see that a needs to be negative. Okay, so I'm going to start off with my skeleton. Y is some number times x minus p times x minus q. Okay. I'm going to plug in, p and q are 0 and 2. And then I'm going to find a using the coordinates of the vertex. Okay, y is equal to 2, and that corresponds to x equals 1. So a times 1 minus 0 times 1 minus 2. And yeah, this is 2 equals -a, and a will equal -2. Okay, so it just took care of itself. I didn't really have to worry about the fact that it was opening down and have to make sure I did anything. I just had to solve correctly. So that's going to be a -2 there. Okay, maybe they don't give us a picture of the graph, but they give us information about the graph, like, hey, there's some zeros over here and there, and there's a y-intercept. Okay, that's different. Okay, that's something that's not a vertex. So I'm going to start off the same way if I'm trying to write an intercept form equation. So it's y is equal to some number times x minus p times x minus q. okay, where P and Q are the x-intercepts. Okay, well, if they say that the zeros are at x equals -1 and x equals 5, then I'm just going to plug in -1 and 5 in for P and Q. So x minus -1 and x minus 5. Okay. And then the y-intercept, y equals 15. Okay, well, a y-intercept, that's a place where x is equal to 0. So I'm going to plug in the point where x is 0 and y is 15 to help me find the value of a. Okay, so I'm going to find a. Okay, y is 15 equals a times x is 0 plus 1 times x is 0 minus 5 is -5. All right, so -5a equals 15. And then a is going to need to equal -3. So I'm going to go in here, and I'm going to substitute a -3. And I'll have myself a an intercept form equation. All right, now I want to go back and talk a little bit more about factoring strategy. We have dealt with cases where the leading coefficient wasn't 1 so far in this unit, but they've all been ones like this one that we're looking at where the leading coefficient divided all of the terms. Okay, so, see how 3 divides 30 and 75? So what we were able to do if we needed to factor this, we would say, okay, start by pulling out the greatest common factor, and I'm left with an x squared, a -10x, and a 25. Okay, and then the thing in parentheses could be further factored. That's been our experience so far. But that won't always be the case that we can pull out that 3 out of every term. Okay, so we had 3, and then I think about two numbers that multiply to 25 and add a -10. That's going to be -5 and -5. So I'd have 3 times x minus 5 times x minus 5, which I could rewrite as 3 times x minus 5 squared if I wanted. Okay, so that's where we were. I'm going to pull in one where that technique is not going to work. All right, yeah, so what about this one? Right? And I've got 2x squared minus 3x minus 9. I can't take 2 out of a 3 or a -9, or if I did, it wouldn't help me factor at all. I'd be no better off than when I started. So I'm going to show you this other technique. Okay, we're used to looking at the last number and finding two numbers that multiply to equal like -9 and add to -3, but that's not going to work for us in this case. What we're going to do instead is we're going to take 2 and multiply it by -9. Okay, so we're going to look for two numbers that multiply to 18, or pardon me, -18. So, yep, that's visible, while adding to that -3. So I'm thinking about it, and it's like, okay, 9 and 2, no. 18 and 1, no. 6 and 3, yes. Okay, 6 and 3, those have like a difference of 3. I can make this work. So since m plus n needs to be negative, I'm thinking that the 6 is going to be the one that needs to be negative, so that -6 plus 3 is -3. And what I'm going to do is I'm going to go over here and say, all right, g of x equals 2x squared. That stays the same. But I'm going to split up the -3x into the -6 and the +3. I didn't actually write this out, but I'm going to let m equal -6 and n be +3. That fits those equations. So I'm going to say -6x plus 3x. Let me just move this down a little bit. Okay, -6x plus 3x, and then I still have that -9. And then what I'm going to do is I'm going to do group and factor. I'm going to look at the first two terms here, and then I'm going to look at the second two terms, and I'm going to factor out the greatest common factor. Okay, from the first two, I'm seeing an even number and an x in both terms, so I'm going to factor out a 2 and an x. And I think, what do I multiply 2x by to get 2x squared? Well, that would be x. And what do I multiply 2x by to get -6x? That would be -3. Okay. And then I'm going to, in this couple of things here, I'm going to say, okay, what's the greatest common factor of 3x and -9? And I think it's just going to be the 3. So I'm going to add 3 times, okay, factor out a 3, and then I'll be left with an x and a -3. And now if you've done this right, you should be seeing the same thing left behind on both. Okay. And then we can factor that out, right? Because this is, again, doesn't really look like it, but it is another sum, right? So I could factor out the x minus 3 from that sum. I'm going to get rid of those black lines. I don't think they're helping. X minus 3, and then what am I left with? Okay, from the first term, I'm left with a 2x. And from the second term, I'm left with a 3. Okay? And so that's how we're going to factor where a is not equal to 1. All right, so maybe you're wondering, like, wait a second, what just happened there? Why does this work? I've wondered that for a while, but I haven't taught Algebra 2 in a few years, and so I kind of just like accepted that it worked, and I wasn't totally sure why. But this year I was like, I really want to understand. And so I went in and I wrote out a couple of them. And what I'm seeing is that, and I remember when I made these notes, I feel like I had a deeper insight than I've got right now. But what I'm going to point out is that, okay, if these are like, this is n, using the terminology I'd used before. If I multiply m times n, I'm going to get negative 24. A negative 8 times 3 is negative 24. But also, if I take that first coefficient, that leading coefficient, and multiply it by the negative 12, right, the AC, a times c, I'm also going to get negative 24, right, because 12 times negative 2. And kind of the same thing over here, negative 2 times 18, that is the same as 3 times negative 12. Okay, 4 times negative 40, same as 20 times negative 8. And if you just like follow it all the way through, you see that it's the same pattern each time. And then the general case, you can see, well, if I multiply BC times AD, that'll be the same. That's the same as AC multiplied by BD. Because we know we can multiply numbers in whatever order we want. 4 times 5, it's the same number as 5 times 4. And if we did 1 times 2 times 3 times 4, well, we could scramble those all up and it would give us the same product. So that's why this technique works. And that's great and everything, but I'm not going to do a whole bunch of these in this video. I'm going to record, I've got an extra practice set at the back of your notes book on this topic that's got a lot of those examples, and I'm just going to record all of those as a separate video. If you need more practice factoring where the leading coefficient is 1, I've got that for you. Okay, now I want to show you about how to write an equation for a parabola that passes through 3 given points. Okay, so what we're going to do is we know we're eventually heading for something like y equals ax squared plus bx plus c. And what I'm going to do is I'm going to use each of these points to plug in on x and y. Okay, because a, b, and c are the things that I'm like setting out to find right now. So I'm going to plug in negative 3 for y and 0 for x. Okay, and then I'm going to plug in 0 for y and 1 for x. And then the third point is x equals 2 and y equals 1, so I plug in 1 for y and 2 for x. And what I've got written down here in red, this is 3 equations. There are 3 linear equations, and there are 3 unknowns, so I'm going to solve this system using elimination. Actually, I'm probably going to do substitution. If you're given the y-intercept like this right here, then you'll always get one of these equations that really simplifies nicely, right? Because 0 squared is 0, and I multiply a times 0, and I'm just going to get 0, right? So this is equivalent to saying negative 3 equals c. And then I can use that I just learned to substitute on these. And so it's not even really like a 3x3 system usually. But you thought you were done solving 3x3 systems in this class, and I'll tell you you're not, okay? Because I really believe that the best time to learn something is right when you're about to forget it. And it's been a while since we've done any of these systems, and I want you to really know what you're doing with these, so I'm going to bring them back in different contexts. And there will be other situations in this year where I will bring the systems back and force you to solve them to continue practicing and improving. Okay, so all that to say, my equations are going to be the second and third, these two. So it's going to be, I might add 3 to both sides and get 3 equals 1a plus 1b. And then add 3 to that bottom equation, and I would get 4 equals square 2 and get 4a and 2b. Hey, if I want to do a limit, I'm thinking about getting rid of b. I'm thinking about multiply the top equation by -2. So that would be -6 equaling -2a minus 2b. And then leave the other equation the same. Okay, add these together, and I'll get -2 equals 2a. That's telling me that a needs to be -1. Okay. I've got a, I've got c, I've got 3 equals a plus b. So I might say, all right, 3 equals -1 plus b. That means b needs to equal 4. All right, so I've done all this work, and my equation is going to be, okay, that didn't go like I'd hoped. It's -1x squared plus 4x minus 3. Okay, so that's us solving for a and b and c. All right, now I think you should try this on your own. Okay, here's 3 other points, and I want you to use the technique I just showed you to try to find an equation for this parabola. And if you're going to work this on your own, then you're going to need to you need to work it while you've got the video paused. Okay, so you should pause now. All right, there it is. Okay, so I started off, I know I'm going for y equals ax squared plus bx plus c. I'm going to plug in x equals 1, y equals 6, x equals -2, y equals -3, and x equals 0, y equals -1 to get myself 3 equations to solve this system, or to set up the system. And then I'm going to solve it the same way I've been doing it throughout this year. I used substitution because it was pretty set up for it. I saw c was -1. And then I got myself down to a 2x2 system right down there. And then I solved it, and I got a is 2, b is 5, c is -1. But I want to point out that that is not the answer, right? That the actual answer is going to be, y equals, no chance of fitting that up there, so maybe I'll just go up here. Y equals ax squared, 2x squared, plus bx, plus 5x, plus c is -1. Okay, and that's how we did that one. All right, now in conclusion, we've kind of started to, get a variety of different forms of quadratic equations and a variety of problem types, okay? And where we're going to try to write a quadratic equation after being given some sort of minimal amount of information. And so I just showed you about writing an equation for a parabola with 3 points. We're going to use standard form, ax squared plus bx plus c. And how we're going to solve it is by setting up a system, okay, system of equations. I don't think we've done one like number 2 quite yet, so I'll do one off to the side in a second. But we have done the one in this video, 2x intercepts and another point. We wanted to use intercept form. That was like, those examples I did at the very beginning of this video where we were looking at the picture of a graph or something like that. Okay, that other point, it could be a vertex, it could have been, one of them was a y-intercept, I remember. And so we plug in our 2x intercepts and solve for y. Pardon me, I meant to say solve for a, right? Okay, and so I might also write out the intercept form, so that's y is a times x minus p times x minus q. Okay, standard form is y equals ax squared plus bx plus c. Okay, but if they gave us the vertex and another point, all right, so if we were given a vertex and another point that the parabola passed through, and I was to try to draw a picture, okay, here's the vertex 5 and 2. And passes through the point where x is 4 and y is equal to 9. Okay, that's to the left and above. Okay, well, if this is the vertex, okay, I know that this is going to be the minimum point. And it's going to open up. Moreover, like I know there's a third point, I can use the symmetry, right? Okay, you can't really see my arrow there, but okay, yeah. It's a pretty good parabola. Okay, so then I reached too far on that one. Okay, if we start with vertex form, which is going to be my recommendation here, okay, we know that vertex form is y equals a, same a as the a in both of the other equations. Okay, use a capital letter A in standard form, I guess, to avoid the lowercase b, because people oftentimes think my lowercase b looks like 6. But this is x minus h squared, where h is the x coordinate of the vertex, plus k, where k is the y coordinate of the vertex. Okay, so I'm going to start off with vertex form. Basically just plug in all the stuff. Some number times x minus 5 squared plus 2. Okay, and now I need to find the value of a using the point 4 and 9. Okay, so find a. Okay, so y is equal to 9. A times 4 minus 5 squared. Okay, so plus 2. Okay, so 9 equals a times positive 1 when I square negative 1, plus 2, and a is going to equal 7. Okay, so I could go back in there and I could substitute, and then I would have myself an equation. So you want to use vertex form, plug in the vertex, solve for a. Okay, or I guess you're going to plug in the vertex, then you're going to plug in the other point that it passes through and use that to solve for. All right, so I think that covers it for this lesson about intercept form. What you really need to do, you need to practice your factoring. You're going to need to practice your systems and just all of these quadratic situations that we've been showing you so far. All right, so that's going to be all. Thanks for watching.